Simple review. Today is the 22nd of May, 2017. You're tasked with mixing up 375 milliliters of 0.2 molar sodium chloride solution. What mass of sodium chloride do you need? What are we solving for in this equation? Molarity? No. Volume? No. What are we solving for? Is mass there? We have to solve for moles and then do a factor label that tells us what mass that will be. So our first step is going to be knowing that the molarity of the solution times the number of liters of solution needed tells us how many moles of NaCl we're going to need. Okay, so things to be careful about. I need 375 milliliters. I have to have my volume in what units? Has to be in liters. So that's 0.375 liters. And my molarity is 0.20. So how many moles of sodium chloride do I need? I've got 0.075 moles of NaCl required. Now what mass of NaCl do I need? Okay, so now what do we have to do? Factor label. 0.075 moles of sodium chloride. We know that 1 mole of sodium chloride is how many grams of sodium chloride? Na and Cl. Okay, so we have 58.44 grams of sodium chloride in 1 mole of sodium chloride. How many grams of sodium chloride do we need? 4.383 grams of sodium chloride. Pretty small, pretty manageable amount. And how many sig figs do we have? Check yourself. 2. We're limited to 2 sig figs, so our final answer for this would be 4.4 grams of sodium chloride. Okay? Questions? You want to do another one, or are you good? Want to just take the FIP quiz? This is a fairly common kind of problem in that we know how many grams of sodium hydroxide we need to run a reaction. We've probably done the stoichiometry and figured out, well, we need this many grams of sodium hydroxide. Oh wait, the only form we have that in is a 0.1 molar sodium hydroxide solution. So how much solution do we need to get the 10 grams of sodium hydroxide that are required? Well, our first step in all of these problems, you're kind of coming from this root. Molarity of the solution is equal to the number of moles divided by the volume of solution. But nowhere in there is mass. So very often in tandem with that equation, we have to do a little tiny factor label. We'll eventually be solving for volume of solution, but right now, first, because we're given molarity, we have to find the number of moles of sodium hydroxide that are required. So we're going to put factor label here, 10.0 grams sodium hydroxide, and we know that 1 mole of NaOH is equal to 40 grams of sodium hydroxide. So what we're looking at here is 0.25 moles of NaOH. Now we're solving for volume of solution, and this is the tricky one because we're solving for something in the denominator. This is where even people who are really good at math tend to make stupid mistakes. It seems silly, it seems like the long way around the barn. I've been doing algebra since before you were all born. I still do all the steps if I don't want to screw it up. Multiply both sides by L, rationalize the fraction, and then I can divide both sides by molarity. So what I get is L equals number of moles over the molarity of the solution. Okay, so now the volume of solution needed is going to be 0.25 moles divided by 0.10 molar solution. We're going to need 2.5 liters of this stuff. Okay, it's a lot of solution. to get 10 grams of sodium hydroxide. That's because it's a really dilute solution. It's not very concentrated. If we were dealing with 1 molar solution, we would need a tiny fraction of that. We would need 1/10 that much because it's a direct relationship. Questions? Okay, so results for the quiz. These were all two-parters. In all of them, you had to do both just the straight molarity equation, 3-part algebra, and solve for it, and you had to do a small factor label. So for the first one, we needed to know how many moles of calcium chloride we were talking about. So we did the factor label to get that, and then we can plug that information into here, and we find that it's 0.25 molar. Almost everybody got that one correct. So, and there were no rounding issues. The sig figs were pretty straightforward. That 2 liters of solution limits your sig figs. So number 2 was a little bit trickier. So we just need to know what volume of solution you need, and you're given a mass of barium nitrate that's needed rather than a number of moles. So first you have to figure out how many moles of barium nitrate are required. The big thing here is that if you round this number first, it makes a huge difference in terms of the volume of solution that you figure you need. Here's the raw answer, 0.3061 blah, blah, blah liters. With sig figs, that comes out to 0.31 liters or 310 milliliters. And a lot of people did everything right, but their sig figs were pretty bad. And those bad sig figs, that's okay. But those bad sig figs make a difference. Like if you rounded this before you put it into your calculations, you're like 30 milliliters off in terms of the volume of solution that you would need. Okay. Last one, and I will post the key, of course, as always. Okay, and this is one where you have to mix 250 milliliters of a 0.1 molar potassium chloride solution. How many grams of potassium chloride do you need? So you can find out how many moles of potassium chloride are necessary, and then you have to go from that moles and convert it to grams, so you know how many grams to measure out. And you get 1.86, etc. grams. But the Fruit Loop who wrote this problem, who should be fired, obviously, for bad problem writing, only gave you 1 sig fig to work with. So, the best you can say is, I need 2 grams. Now, that said, how precise is your lab scale? That's what's going to depend on how much you can measure. If you're working with a lab scale that goes out to only the tenths, you're probably going to measure 1.9 grams. And if you're working with something that's a little bit more precise, like what we have here, you can do better. But yeah, 2 grams of potassium chloride would be the correct answer with sig figs. Okay, questions? Okay, for the first challenge problem on the back, you're told you have a 2.5 molar iron bromide solution. It's at 50 degrees Celsius. Is it saturated, unsaturated, supersaturated? So you know the difference between those terms. You're further told that about we should assume that 88% of the volume of the solution is made up of water. The iron bromide does take up some space. So in 1 liter of that solution, we're not going to have an entire liter of water. If we figure out how many grams of iron 2 bromide would be in a single liter of that solution, we find that it's 539 grams of iron 2 bromide that would be present in that solution. Well, if we assume that 88% is correct, then in 1 liter of solution you would also have 880 milliliters of water. So you can then go from 880 milliliters of water, and looking at the values for solubility up here, you can figure out how many grams of iron 2 bromide that 880 milliliters of water should be able to dissolve. And what we find is that we're way under. So 880 milliliters of water should be able to dissolve 1,267.2 grams of iron 2 bromide. So this solution is very unsaturated. It could accept a lot more solute. And very often, 1 and 2 molar solutions are generally not saturated. I used to do a problem, and we just kind of don't have time, where I said, what would be the molarity of a saturated solution of something? So anyway, that's it. We'll pick up tomorrow. Homework. These problems, grade tomorrow. So the bookwork graded tomorrow.
Is that on our main A and B?
Parts A and B only, yeah.